and welcome to the videos on the definite integral. So definite integrals are basically just antiderivatives between 2 points, and they're used to find things like areas under curves. The thing with a definite integral is that it's always going to have the terminals, which are the upper and lower values that we are evaluating the integral between. So the way that we do a question like this is we start off by anti-differentiating. I'm going to use some nice big square brackets. This is the notation that's used, but basically do the antiderivative of x, which just comes out to be x squared over 2. Remember, you raise the power by 1 and then divide by the new power, and that's being evaluated between -2 and 2. The next thing I have to do is I have to substitute in the upper terminal first, and then I'll substitute in the lower terminal. So when x is equal to 2, I'm going to get 2 squared, which is 4 over 2. Then I have to write a minus sign, and I'm going to sub this -2 in, which also happens to be 4 over 2. So the answer there is just a number minus itself, which is going to be 0. Now, there's this sign here, which is always going to be a minus sign, okay? You know, there are a few exceptions where it might change to a positive or something like that, but basically that's just the way that it's worked out. And this is a really interesting problem because we've got the answer of 0. Now, you might remember me saying that what we're actually finding is the area under a curve. And well, we wouldn't expect that this graph would have an area of 0, you know, given that it's between -2 and +2. So what I want to do just off on the side, and you know, this is perhaps going ahead a little bit, but I'm going to just show you what it was that actually happened. So I'll just quickly draw some axes here. And the equation is y equals x, so that's just this line going through the origin here, like so. Now we're looking between -2 and +2, so let's say here's -2. And out here we have +2. The area that we've just found is this bit in here, as well as this bit in here. You might be having a few ideas about this now, but we can see that both of those areas are the same, you know, given that this is a symmetrical shape about the x-axis, and well, basically this area here and this one over here are the same. So the fact is that this one here is above the x-axis while this one here is below the x-axis. And what's actually happened is these areas have cancelled each other out. So this part here would have a negative area because it's below the axis, it's got a negative height, whereas this one over here on the right would have a positive area given that it's above the x-axis, so it has a positive height. So, you know, if we want to find the actual area, we have to do a slightly different calculation, but yeah, what we've actually just found is what's called the signed area. And anyway, that's probably all I need to say about that, but just thought it was a nice little introduction to that sort of problem. Now let's move on. So going and doing a similar thing here, we've got the terminals of 1 and 3. We're looking at the function x cubed plus x squared. So again, what I'm going to do is anti-differentiate. So that's going to become x to the 4 on 4 plus x cubed on 3. And that's between 1 and 3. So then I substitute in those values, the upper terminal first, so 3 to the power of 4 is going to be 81 over 4. And 3 to the power of 3 is 27 over 3, which is just 9. So that was what we got from subbing in the first terminal. Then I put the minus sign, and now I substitute in the 1. So I'm going to get 1/4 plus 1/3. And that can really be simplified. So I've got 81 over 4 minus 1 over 4, which is 80 over 4. So that's going to be 20. I've still got plus 9. And I'm going to have minus 1/3. So I think I have to finish this in the next video.